Hello guys, welcome to the Have a Lab. Today my name is Babatunde Arolo, and today we're going to be talking about basic properties of logarithms, okay? And what this means is we're going to use our knowledge on logarithms, and we're going to use that kind of evaluate some certain equations. So those equations we're going to, based on our knowledge on logarithm basically, right? Basically what we learned from logarithms, we're going to implement it into these equations, and we're going to see which of which is true, and we're going to see what makes what true. Okay, so this table I've given here represents some of the basically represent the properties of logarithm. Okay, so let's look at this first one. This first one is saying log 2 bracket a times b. Okay, so I'm using log 2 here as an example. There can be any logarithm, you can be working with any logarithm here, but I'm using log 2 as an example. Okay, so let's say we're given log 2 times bracket a times b. This is the same thing as log 2a plus log 2b. Okay, so wherever you see log 2a plus log 2b, that's the same thing as log 2 times a times b. Okay, so once again, you can use any logarithm you want. It doesn't matter if it's 2 or whatever, you can use 5 or whatever, right? Okay, so that's the same approach we're going to use in this second property. So this is going to be log 2, but in this case, we're dividing a by b, okay? And since we're dividing a by b, it's no longer going to be a plus. So in this case, it's going to be a minus now. So it's going to be a log 2a minus log 2b, okay? And this is the power properties of logarithm. So basically, this means that whenever we're given a logarithm, like in this form, like in log 2a raised to the power b, this is a, not 9. This is log 2a raised to the power b. It's the same thing as b, because we're going to put the power in front of the logarithm and multiply that by the logarithm of a in this case, okay? So we're going to put in those properties into this equation. So let's take a look at this equation. This is log 5 base 11 minus log 5 base 9, okay? And if you take a look at this table, the only part where we have log, where we're working with a minus basically is in this second one. Okay, so we have to look at the second one in regards to this question, because we're working with minus. Okay, so this is log 2a over b equals log 2a minus log 2b. And so whenever we're subtracting logarithms from each other, that basically means we have to divide the logarithms. Okay, so in this case, since it's 11, log 5 is 11 minus log 5 is 9. Okay, so that means we have to divide 11 by 9 in this case. Okay, so basically, I'm write that down. This is log 5 is 11 minus log 5 is 9. Okay, so this is going to be equals to log 5. Okay, based on this, right? This is going to be log 5 to 11 over 9. Okay, so let's put that in first. This is 11 over 9. Okay, so we're done with that. Okay, so let's look at the next question. The next question is dealing with an addition. Okay, so this is an addition, and whenever we're adding, we have to multiply the variables together. Okay, so this is basically the same thing as, okay, so in this case was we don't know what this part is, right? So it is very advisable to put in a variable or whatever you want to put in. So it's kind of like we're working our way, by using variables in this case. Okay, so we already got this side of the equation, but we don't know what side this is. Okay, so this is saying log 9 base x, so we can replace the square with x in this case. It's plus log 9 base 7 equals log 9 base 56. Okay, so and when we're dealing with plus basically means a times b equals log 2a plus log 2b, right? So basically this means this here, this 56 is the same thing as 56. So this is saying 56 equals log 2a times b. Okay, so this is log 9. Sorry. Log 9 a times b. And in this case, our b is 7, right? Okay, so we'll say log 9 to 56 equals log 9 to a times 7. Okay, so this is 7a. Basically, this is 7a. We can say, all right, this is 7a. Let me just, this is 7a. Okay, so now since the logarithms are equal, we can kind of ask ourselves, basically, what do you think when I multiply by 7 is going to give me a 56? And in order for me to do that, I can think of this as a normal equation. I can take out the log 9 for now, right? I can take out the log 9 and just kind of work with this on its own. Okay, so when I take out the log 9, what I'm left with is 56 equals 7a. Okay, because I'm taking out the log 9 now to find a. Okay, so I have to find a in this case, right? And for me to find a, I have to divide both sides by 7. Okay, so when I divide here by 7 and here by 7, I get a equals 8. Okay, so a in this case will be equals to 8. So let me put that in 8. Check that out. Oh, okay. Not done yet. Okay. And the last one, this is 3. I'm write that down. This is 3 log 8. 3 equals log 8x. Okay, so it doesn't matter. You can put in an x if you want. Um, when you're given this kind of stuff, right? Okay, so let's take a look at this example. This is b times log 2 base a, right? So if you look at this, it's kind of the same format as this, right? The only thing is that in this case, b is 3 log, the logarithms are different and the a is different, right? But it's kind of the same format, right? So we're going to use that format to kind of solve this question. Okay, so when it's in this format, what we do is we take in the log 2, the log remains the same, and but then we set the b as an exponent here. So the b becomes the exponent here, and a becomes the base. Okay, so that means we're going to set this number as the power up here and set this 3 as the base. Okay, so this becomes log 8 to the power to 3 raised to the power 3. Okay, so this becomes log 8 to base 3 raised from, or 3 raised to the power 3, which is equals to log 8 is 27. Okay, so let's check that out. Yeah. Okay, so thank you very much for watching the video. I really hope it helped out, and have a beautiful day ahead.